That's why it will look like that big blob, as Cadence just said. Our water wants to stick to itself so much that some creatures can walk on it. This is because of surface tension. All those water molecules are holding hands really tightly. They're attracted to each other. It makes it so small, light objects can balance on the top. We are going to play with some of the properties of water together now. To start, we need to have a big glass filled with water. We want to fill it up as much as we can. We want to make sure that we work over our bowl. We do not want the water on our computer. So I put a very full glass of water in my bowl. I'm going to wait just a little bit so everybody has a full glass of water before we start. Julia, do you have a really full glass of water? Excellent. Elin, do you? Excellent. Dean, do you have a really full glass of water? Yes. And Audrey does? What about Cadence? Yes. Okay, we're ready to continue then. We are going to use our pipette. Our pipette is a tool that can help us suck up liquids. To use it, we stick it into our liquid and we squeeze the top, the bulb of our pipette. When we release the top, it sucks up liquid. When we squeeze the top again, out comes our liquid. I would like us to try filling our glass up even more with water by using our pipette. So we're taking pipettes filled with water and pouring them into our very full glass of water. We want to fill our glass until it overflows. Yeah. So we want to make sure our glass is inside of our bowl when we do this. That way we don't get our computer hurt. So we are pouring the water into our already filled glass. So our glass was really full. We're going to put more water into our already full glass. We want to see how close to the top we can get, and then how much more water we can fill in that glass. Audrey, you have an observation you want to share?
That a lot of the water spilled because it got so high, it got over the part.
You notice that your water is above the edge of your glass? Ooh, that's a cool observation. Cadence, you want to share something with us?
When it overflows over the glass, it's like overflowing onto an island like a flood.
Ooh, yes. So we see that our water is going to stick together in a little island. And Cadence told us about how the water forms a little bit of a layer over the top of our glass. Our glass isn't even holding the water when it gets really full. It's above the top of our glass. That's because of surface tension. So all the water is strong enough to hold itself together. We're going to try playing with the surface tension a little bit longer before we move on to our next activity. Cadence?
What if we put a coin in? It would push more water out.
You already know what the next activity is, yeah. So we're filling our glass up as close to the top as we can. We're going to spend about 30 more seconds filling our glass up before we move on to our next activity. Okay. We are now going to take out our coins that we got from our house. We are going to slowly and gently drop them into our glass of water, one at a time.
I only got a coin.
Oh, do you want to go see if your parents or someone in your house knows where some coins are? In your bag, you have one special coin. We want to use some that are in our house. Yes, Dean.
What is this Japanese coin for?
Oh, we're going to do an activity with it in a little bit.
Oh, wow.
Yeah. And then you get to keep it. So we need some other coins from inside of our house. We are slowly dropping our coins into our glass of water and noticing what happens.
How many do we need?
6. They can be any coins you want.
Can't, we need 6.
What do we observe when we drop our coins into our glass? Julia, what do you observe?
It just sink at the bottom of the glass.
Ooh, so our coins sink. That means they're really dense. Great job, Julia. Elin, did you want to share something?
That it feels really light, but it sinks down.
Ooh, yeah. So they're small, but they're dense. That's why they sink. Audrey, what do you observe?
That one of my coins, then one of them floated and the other sank.
Ooh. So yes, we can try using some of our coins from our house. And you have a coin in your bag of supplies for today. We can try floating or sinking that coin and see what happens. Does it float or sink? Audrey?
It sank.
Ooh, yes. So we see that all of our coins sink if we drop them straight down into our water. We're going to try another activity now. We are going to try to slide that special coin that we got in our bag of supplies across the top of our water. We want to see if we can balance it on the top of our water. If yours sinks, you can get a fork. You can try to slide it across the top of your water. So we're taking our coin, we're sliding it across the top. The special coin, our Japanese coin, our yen, should be able to float on the surface if we put it really flat. This is because we have surface tension of our water.
Mine still sinks.
Okay, I'm gonna get to how we can fix that in a second. So we can fill our glass up even further. So our water is all the way across the top of our glass. We can then take our coin and rub it on our skin. We want the oils from our skin to help us so we can put our coin on the surface of our water. We can also try doing the same thing with our paper clips. So we have paper clips and that 1 yen coin. We're sliding them across the top of our glass on our water. We're going to try to put them up on the surface. This is really hard. You have to be very good at balancing your coins and your paper clips. The surface tension of your water, it's strong enough to keep the water together, but it's not very strong. This is why it's really hard for you to put your paper clip on the surface of your water. The surface tension of our water is strong enough for a water spider to walk on though. So these bugs, they walk on the surface of the water, and the water holds them up so they don't sink. This is because their legs are spread out across a huge amount of their water. This allows them to have enough surface tension underneath them that they can balance on the water. This is why it's really hard for us to try to float some of our coins on it, because our coins are dense and they have a small amount of area, small amount of water that they touch. It would be impossible for us to balance our paper clip if we put it this way. But if we lay it flat, some of us can balance our paper clip. Audrey, you are raising your hand?
That if you put the paper clip and the pipette together, then you could put, then if you have them together, then if you put it in water, then it might be able to float.
Yeah, you're talking about floating and density. Great job applying what we learned last class to what we're doing now. Great job, Audrey. Does anyone else have any observations about what they're doing that they want to share? No? Okay. We're going to spend about 1 more minute seeing if we can use surface tension to hold a paper clip on the surface of our water. So we can slide it across the surface of our glass. It'll make it a little bit easier for our paper clip to balance on the surface of our water. We want to have our glass really full. So like Dean, if your glass is even more full, it will help you so you can balance it up on the surface of your water. Audrey, you're raising your hand. Do you want to mute yourself?
I just learned that it worked.
Yeah. Excellent job. So you had a prediction about what you thought would happen with your paper clip and your pipette. And then you tried it and you observed what happened. You used the scientific method. You ran your own experiment. Great job, Audrey. Okay. We're going to start to work on our next activity. Dean, you're raising your hand. Did you want to share something?
So mine's floating on top of my water.
Yes, great job. You can see the Dean, and I'm guessing that was a parent that I saw. They managed to float their coin on the surface of the water. That was actually that they balanced it because of the surface tension of water. Great job. We are going to start our next activity now. We need to have 2 of our coins out of our glass for our next activity. So I have 2 coins. We want to dry off our coins. We want them nice and dry. Can we dry off our coins? And then we're going to put our coins on a plate or in our bowl. We want them to sit flat. We're going to use the surface of our coins for our next activity. I'm going to wait just a little bit longer so everybody has 2 dry coins to use. Okay. We are going to be using our pipette to put drops of water onto one of our coins. We want to count how many drops of water fit on a coin before it flows off the edge. So count how many drops. When your water flows off the edge of your coin, you're going to raise your hand. You're going to share how many drops of water you were able to put on that coin. Cadence?
I was able to put 14 drops on my coin.
14 drops. Great job. We want to write down how many drops we were able to put on our coin because we're going to do another experiment with that number. Dean, how many drops were you able to put on the coin?
I was able to put 20 drops.
20. Wow, great job, Dean. We want to write down that number. Audrey, how many drops were you able to put on your coin?
5.
How many?
5.
5. Those must have been big drops. Julia, how many drops did you put on your coin?
15.
13?
15.
15. Great job, Julia. And I think Elin is our last person putting drops on her coin. Oh, yeah. Do you want to unmute yourself and tell us how many drops?
I did 15.
15. Ooh, great job, everybody. We are now going to try another experiment. We are going to take our pipette and our bottle of oil. We are going to see how many drops of oil we can fit on our other coin. We're going to make a prediction first. Who thinks we can put more drops of oil on our coin than our water? Who thinks we can put less drops of water on our coin than we did our water? Ooh, let's test our predictions. So we're going to put some drops of oil on our coin and count how many drops we have. When your oil flows off the edge of your coin, raise your hand. Elin, how many drops were you able to put?
10.
10. You had 15 before. That's less amount of drops. Audrey, how many drops did you put?
5.
5. Ooh. Cadence, how many drops were
I
you?
used a coin the same size and it was 25.
25. Ooh. Dean, how many drops did you put?
I kind of lost track, so I counted 2,000 drops, but I actually dropped 15.
Oh, 15. I think we have one more person working. Julia. Oh, you're done too? How many drops did you put? 10. So I heard that a lot of us dropped less drops of oil on their coin than they did water. Our data taking helped us so we could see whether our hypothesis was true. So who here thought that we could put less drops of oil on our coin? Yeah, I see a lot of us did. That means our hypothesis was true. Our data supported our hypothesis. Cadence, you want to share something?
Or kind of means it's mostly true because I got more drops on my thing with oil than with water.
I wonder whether our drops were the same size. Because if our drops were of different sizes, then we would not actually be proving anything. Yeah. So we can test this again. Let's see what happens again. We're going to try putting drops of water on our coin and drops of oil on our other coin. We're going to look and see what happens this time. So we are observing with our eyes. Ooh. So who is making any observations that they want to share? What do you see? Yes, Audrey, what do you see?
That the one on the coin that I put water on, it turned darker, and the one on the other coin that I put oil on, then it turned the same color, but a little lighter.
Ooh. So our liquids act as lenses to change what the light is coming through and into our eyes. That's why we see the color change. Great job, Audrey, for that observation. Cadence, you have an observation?
I realized if you put drops of oil on the water, it will make blobs, and then when you stir it, it will make tinier blobs.
Ooh. Yes. So our oil and water do not want to mix. There's a term called hydrophobic that describes oil. So that term means that our oil doesn't like the water. It's afraid of the water. That's why it doesn't mix. And we see those blobs that Cadence was saying. Who notices anything about the shape of their water or oil on top of their coin? Yes, Audrey.
So the one on my coin that has oil, it was a big blob, but on the other coin that I had water on, it was a little blob.
Ooh. So we're seeing that they're in blobs, as Audrey's saying. We're seeing the surface tension. We're seeing that our water and oil wants to stick to itself. Great job, everybody. This isn't just us that sees those blobs of water on coins. This happens when everybody drops water on top of their coin. We can see that the water forms big droplets. The surface tension of the water is strong enough to keep all the water together. Cadence, you want to share something?
What if we put water on the oil?
Ooh, we're going to do something with water and oil soon. Okay. So Cadence was talking about how water and oil work together and how they don't want to mix. We're going to do an experiment with that in a second. Audrey, you want to share something?
So then when I learned that, then the oil and the water, they kind of attached, but then they went away. And then they kept doing the pattern. Attach, away, attach, away.
Ooh, so we're talking about how strong our surface tension is. But it's not strong enough to hold a whole bunch of water. It only has a certain amount of strong, but it can only hold so much water before it breaks. Elin, you want to share something?
So I mixed oil and water really good where they kind of mixed it. But I took them and I put them on a coin, and it's like really like a really big bubble.
Ooh. So you're seeing that oil and water together. If you stir them up, you see lots of small droplets of oil. Great job, Elin. Thank you for sharing your observation. We are going to use the properties of oil and water to make a new toy together. Yeah. To start, we need to fill our tiny bottle halfway with water. We want to remember to do this over our bowl. If you have a funnel, you can fill your bottle a little bit easier. We do not want to spill water on our computer. So I've filled my bottle about halfway with water. I'm going to wait until everybody has a bottle that's about halfway filled with water. Dean's noticing that his bottle floats because it has air in it. Okay. Does everybody have a bottle that's about halfway filled with water? Audrey does. Cadence does. Dean does. Elin looks like she's drying the outside of her bottle. We're going to give Julia just a little bit longer so she can get her bottle about halfway filled. Yeah, we want a little bit more water in that, Julia. We want about halfway. Okay. We are now going to put some of our oil into our bottle. So we're going to pour some of our oil into our bottle. We want to get our bottle most of the way filled. Mm-hmm. So we're filling our bottle most of the way with oil now. We now need our parents' help. We want to put some food dye into our bottle. Just a couple drops. We want to watch really closely and see what happens to the food dye. So we're putting some food dye into our bottle and we're watching really closely. Yes, Cadence.
If you want to stand your bottle up while you're doing it, you can put the lid on the bottom of it.
Ooh, that's a cool idea, Cadence. We still want to make sure this isn't near our computer though. Oh. So what do we observe is happening? Who wants to share? Elin, what do you see is happening?
It's like all sinking down to the bottom.
Ooh, so our food dye wants to sink to the bottom.
It also, it's not good. The food dye didn't want to go in the oil.
Yeah. So you had 2 observations. Great job, Elin. Cadence, what do you observe?
Mine sat as a ball at the top for a bit and then it went down like syrup.
Ooh, yes. So we saw that our food dye formed little balls when it was inside of our oil before it sank. Audrey, what did you observe?
I observed that when I put the food dye in, then it actually just bubbled up so high.
Ooh, so we see bubbles of our food dye. Thank you for your observation, Audrey. Why do we think that this is happening? Who has an idea? Elin.
Because the oil probably has different chemicals, so the food dye doesn't want to go in it or want to mix with the water.
Ooh, yes. So you told me that oil has different chemical properties than your food dye. That is true. Oil is a lot different than food dye. It's a lot different than water as well. So we noticed that our oil and water didn't want to mix. Food dye is color plus a lot of water. So we just saw that our food dye, that's water, doesn't want to mix with our oil. It was another observation that was very similar to our first one. Cadence, you have another explanation for what we're seeing?
The oil's pushing away the dye, but since the dye's all spread out, it made little balls.
Ooh, yes. So we're seeing the little balls form inside of our oil because our oil and water do not want to mix. Can we apply some ideas about density to this? Yes, Dean.
So I noticed that there's the oil and the water and the food dye. And also when I put it in here, you can still float even when it's too heavy.
Ooh, so we're seeing that if we were to float this entire bottle in water, it still floats. That's
Yeah,
because
so
our-
so it's not like really touching the ground. You just float it up a bit. You can put the Japanese corn at the bottom, and so it's far apart, just like the oil and the water don't want to mix together. So the plastic bottle and the corn don't want to stick together.
Ooh, yes. So you're seeing density, that your bottle's floating, and you're seeing that the oil and water don't want to mix. Great job on your observation, Dean. Thank you. Did anyone want to share any more observations before I describe some of why this is happening with science? Audrey.
I learned that if you actually put some more water in and then you mix it up, after you mixed it up again, before that again, then it actually stops bubbling.
Ooh, that's because all your bubbles are actually really small. You spread out your water evenly through your oil if you mix really well. When you let it sit, it will separate out again. This is because our oil and our water do not want to mix. Our oil is hydrophobic. Our oil is also less dense. It's more buoyant than our water. That's why it floats. So all of last class, we talked about things that float. We're seeing it inside of our bottle. Our oil floats on top of our water. What happens if we turn our bottle upside down? What do we observe? Yes, Audrey, what do you observe?
I observed that the water, it actually goes with when we turn it.
Ooh, yes. So our liquid inside of our bottle moves when we turn it. What about what's on the top and bottom? What do we observe? What's on the top? Yes, Audrey, what's on the top?
On the top is the greenness after you turn it.
Ooh, if we let it sit for long enough, see how you have a light colored fluid at the top when you let it sit for a long time? That's our oil. Our oil wants to float when it's upside down. If we were to turn it back and wait for a long time, we see that our oil still wants to float. They're also still separated. We are going to play with our bottle and see if we can come up with any more observations. Audrey, what's an observation you notice?
I observed that if you actually get it in your tube, then it actually makes it. So then your tube actually has it in green, and it goes up in your tube, and then when you squeeze it again, it kind of looks different.
Ooh. So you observed that when you use your pipette to suck up liquid, that some of that liquid mixes. We're seeing that our oil and water are dispersed. That means they're spread out in each other. The same way as if we were to shake our bottle, we see that they spread out. What's happening is we see little tiny droplets of our oil and water. So let's make sure our cap is screwed on and shake our bottle and look really closely. Can you see the droplets of oil and water? We're going to hold it really still and see what we see. When we hold it still, does anyone observe some droplets in there? Dean, you do? Oh, you just muted yourself. You were unmuted already.
So what I observed is when I shake it like this for about 1 minute, so the oil and the water wants to mix up with the green food coloring.
Yeah. So we see it sort of dispersing. Means they spread out in each other. So I shook up my container as well. Can we see our big droplets in here? I see a couple big droplets of my water that's dyed green, but it's slowly separating. We can look in the bottom. You can see little bits of your oil in droplets as well. That's what those shiny, like clear yellowish bits are. That's our oil. They're in little tiny droplets. Audrey, were you raising your hand? What did you want to share with us?
I wanted to share that I observed that when you you turn it over, then the droplets on the sides, they kind of get littler when you do it more.
So you observed that when you change which way your bottle is, up and down, that some of your water will stick to the other water. And so it'll go down with the rest of your water at the bottom. That's what's changing. That's why you see the smaller drops up at the top. Do we have any last observations? Elin, what do you observe?
It's not really an observe, but I put a drop of food coloring in my bowl, and then like sucked it up with my pipe and put it on the coin, and it looked like really cool.
Ooh. So you put food coloring on top of your coin. You like how it looks?
Mm-hmm.
Yeah. Thank you for sharing that with us, Elin. We are going to use science to clean up now. So we know that water wants to stick to itself. So we are going to take one piece of our paper towel. We're going to put just the corner of it into some water that's on our pennies or coins or in our bowl. So we're taking one tiny corner of our paper towel and we're putting it into our water. We want to watch really closely. We're going to hold our paper towel there and watch really closely and see what happens. Audrey, what do you see?
I observed that it just sank, but part of it kind of floated at the first part and then it sank.
Ooh, so you observed that parts of our paper towel will float originally if we were to put it into our water. We're going to hold the entire piece of paper towel. We're going to put just the corner into our water and hold it there. We're going to watch the paper towel really closely. What's happening to your paper towel? Cadence, what do you see?
It's absorbing the water.
Ooh, it's absorbing the water. So that means that our water is being attached to our paper towel. Audrey, what do you observe?
I observed that when you put the paper towel in just the corner, then it actually looks darker.
Ooh.
And it feels wet.
So our water is being absorbed onto our paper towel, which is why it feels wet. That's because the water is sticking to your paper towel. Who's noticed how their water moves on their paper towel? Audrey, how does it move?
So if you put more of the paper towel in, then it moves, the water moves around and it gets all that paper towel that you put in.
Yeah, so it gets our paper towel wet. What do you observe, Dean?
So I ripped off a piece of my paper, get to put it on the side of my tall cup, it actually sticks to the side.
Ooh. So it might stick to the side of our cup
So,
if it's wet.
so it looks like this.
Yeah.
And the Japanese coin doesn't want to stick to it.
Ooh. Thank
So
you.
it's staying in one spot and it's not even moving. Because the paper towels doesn't want the Japanese coin to stick to it.
Mm-hmm. So it sticks because it's really wet and we can form a suction between our paper towel and our cup. It's a nice observation. Thank you, Dean. if I stick my paper towel in my water, our water will actually climb up the paper towel. I'm going to put some food dye into a cup so you can see this happen. So I have water in a small cup. I'm going to put some food dye in there. Then I'm going to stick my paper towel into my cup. We're going to watch really closely and see what we can observe. Can you see the water climbing up my paper towel? Yeah. So I only have a little tiny corner of my paper towel in that water, but it's climbing up. That's because water wants to stick to itself, but it also wants to stick to my paper towel. So it will climb up my paper towel. This is cohesion and adhesion. So cohesion, water molecules want to stick to themselves. We have surface tension. Adhesion is the water molecules want to stick to our paper towel. That was why our paper towel absorbed water. Great job, everybody, of being scientists today. We're going to go around and talk about what our favorite part of today was before we move on. Audrey, what was your favorite part of today?
My favorite part of today was when we put the food dye in the test tube. That was my favorite part. And then we put the food dye and the water together, and the other one, and the oil together.
Ooh, excellent. So you get to keep this bottle. And if it's nice and closed up tight, you can still play with it after class. Julia, what was your favorite part of today?
The bottle thing.
Ooh, you liked making our toy as well. So you get to play with it as well after class. Dean, what was your favorite part of today?
Oh, so my favorite part was that we get to make this and how my paper towel and penny, so the paper towel stick to my bowl and have a penny floated, but after and since a while, it just sank.
Ooh, I'm glad that you liked doing all of those activities, Dean. Thank you for sharing what your favorite part of today was. And Cadence, what was your favorite part of today?
My favorite part of today was mixing the oil, the water, and the food dye.
Ooh, you also liked making a bottle and playing with the properties of oil and water.
Will you put red in pink?
Inside of your worksheets, there are some other activities that you can do at home after this class. There are also some questions that you can ask yourself. That way you can understand the science behind what's happening. Thank you all for being great scientists with me and making observations. We will come back next week on Wednesday to make some bubbles. Bye-bye, everybody.